Good learners, welcome back to our second class of integration. In today's class, we are going to be looking at how do we apply the general formula of integration to solve the integral integration. Now, before I proceed in my lesson, I would like to invite you to subscribe to my channel, which is Aliphatic Teaches. Subscribe and click the notification bell for my subsequent content. And do well to share to other people for them to also benefit. So in today's class, we are going to proceed properly and you enjoy it. Example 1. If the y dx is equal to x cubed minus 2x squared minus 3x plus 1, find y. It means a function has been differentiated. Then we want to go back to the initial function, which is by integrating that function. To integrate this, we introduce the sign of integration, which is the integral. Integral dy dx equals to integral, open your bracket, x cubed minus 2x squared minus 3x plus 1. Then cross multiply. Integral dy equals to integral x cubed minus 2x squared minus 3x plus 1 dx. Now, integral dy equals to, open these brackets, integral x cubed dx minus integral 2x squared dx minus integral 3x dx, then plus integral 1 dx. When you integrate dy, we are going to have y equals to, when you integrate it, we have x is power 3 plus 1 over 3 plus 1 minus 2x is power 2 plus 1 over 2 plus 1 minus 3x. Don't forget there is a power of 1 here. 1 plus 1 over 1 plus 1. Then plus. When you integrate a constant, it will give you the letter which is in forms of this x. Because this x is going to be x is power, is going to be x is power 0. Then as a constant 1 over 0 plus 1. That's it, plus 1 over 0 plus 1. That is, anything is power 0 is what? 1. So that is why we are talking about in terms of x here. So that's why this x power 0 plus 1 then divided by x plus 1. Therefore, y equals to x power 4 over 4 minus 2x power 3 over 3 minus 3x power 2 over 2 plus x. Because 0 plus 1 is 1 and x power 1 also is what? 1. So this is the final answer of integrating this differentiation. So we arrive at this point. Example 2. Integrate 2x in bracket 2x squared minus 3x plus 4, close the brackets, with respect to x. What does it mean is, this function has been differentiated already, now we now want to integrate it. This can be written as dy dx is equals to 2x in bracket 2x squared minus 3x plus 4. So the first is to open this bracket. 2 times 2 we have 4. X times x squared we have x power 3. I believe you understand how we arrive at that. That is x multiplied by x power 2. This x has a power of 1. In your indices, you pick one of these x, raised to power 1. This multiplication will change to addition at the power. Then we now have 1 plus 2, we have 3. That's how we have as 4x cubed. Then minus 2 times 3, we have 6. X times x, we have x squared. We have 1 here, 1 plus 1 equals 2. Plus 2x times 4, we have 8x. So this is our dy dx. The next step is to cross multiply, or sorry, to introduce our integral value. Integral dy dx equals to integral brackets 4x cubed minus 6x squared plus 8x, close the integral, close the brackets. Now cross multiply here, integral dy is equals to integral, open brackets, 4x cubed minus 6x squared plus 8x, close the bracket dx. Now let's open these brackets. Integral dy equals to integral 4x cubed dx minus integral 6x squared dx plus integral 8x dx. Fine. When integrate dy, we have y is equals to integration of this, we have 4x power 3 plus 1, we have 4 over 4 minus 6x, 2 plus 1, we have 3 over 3 plus 8x, 1 is here already, 1 plus 1, we have 2 over 2. Okay? Then this 4 cancel 4, 3 here 1, 3 here 2, 2 here 1, 2 here 4. So y equals to x power 4 minus 2x power 3 plus 4x power 2. Don't forget, we're going to put a constant plus what? Plus c. Likewise, in the example 1 we did before, we are going to put a constant c. So when you are solving indefinite integral, after your solvings, you must put a constant what? C. So this is the integration of this differential function. Example 3. Integrate 1 minus x over x with respect to x. Before we proceed on this example 3, don't forget to share this class and also subscribe and click the notification bell as we move on. Now, we want to integrate this. Don't forget it has been differentiated already. dy dx is equal to 1 minus x over x. This one as it is, I can refine it and reframe it to give dy dx equals to 1 over x minus x over x. Then x here 1, x here 1. So dy dx, we have 1 over x minus 1. Then let me now introduce my integral value. Integral dy dx is equals to integral, open your bracket, 1 over x minus 1, close brackets. Cross multiply, integral dy is equals to integral 1, open bracket, 1 over x minus 1 dx. Let us open bracket here. Integral dy is equals to integral 1 over x dx minus integral 1 dx. When you now integrate the y, I have y is equals to integration of 1 over x. Let's go back to our basic integrals. When you integrate 1 over x, 1 over z, 1 over anything to give us ln x. If it is 1 over z, it will be ln z. If it is 1 over f, it will be ln f. But in this case, it's in terms of x. So 1 over x, the integration gives ln x. Likewise, when you integrate 1 over x here, it gives ln x minus integration of a constant here. When you integrate this one, it gives what? X. Then introduce a constant c. So this is the integration of this function dy dx. Next question, example 4. Integrate 1 over x plus cos x with respect to x. When you integrate this, or if you want to integrate this, definitely it has been differentiated earlier on. So this means dy dx is equals to 1 over x plus cos x. Let us introduce our integral dy dx equals to integral put a bracket 1 over x plus cos s close the brackets. The next one is to cross multiply. Integral dy equals to integral put a bracket 1 over x plus cos s dx. After the cross multiplication, when you integrate dy, I have y equals to, you open this bracket, integral 1 over x dx plus integral cos x dx. So y equals to, when you integrate 1 over x, from what we have here, 1 over x gives ln x plus, when you integrate cos x gives us sin x. So sin x, then you introduce your constant c. So you have already integrated that function, dy dx given to us. I believe you are finding this class interesting. If not, tell me where there is problem in the comment section. Then I will respond to it in my subsequent classes. Now, let's proceed. Example 5. Simplify integral x squared plus 3x plus 2 divided by x plus 1 dx. When looking at this, the integral symbol has been introduced, which means that this has been differentiated already because we can find the x here. So when we now look at this, it's quite different from what we have been doing so far. Here, x squared plus 3x plus 2 over x plus 1 cannot be done using the first example. But we can factorize this value, x squared plus 3x plus 2. Let's quickly do this. X squared plus 3x plus 2. In factorization, use the last value to multiply the first one. 2 times 1, we have 2. The sign, plus times plus, we have plus. So let me say multiplication, addition. When you multiply the last value, 2 times 1, we have 2 with the sign plus 2. The center value here is plus 3. You will look for two factors. Now when you multiply them together, you will get plus 2. When you add them or you subtract them, you will get plus 3. When you look at this, the factors are going to be 2 and 1. Let us guess the sign. I'm guessing plus, plus. Don't forget, my first assumption is when you multiply them together, you must get plus 2. When you add them or you subtract them, you must get plus 3. Okay, let's multiply. Plus 2 times plus 1. Let's add. Plus 2 plus 1. Fine. Okay, plus times plus. I have plus. 2 times 1. I have 2. Fine. Here, plus 2. I have 2 naira with me in my first pocket. Plus 1. I have 1 naira with me in the second pocket. How much am I having together? Definitely is 3. That is plus 3. So the plus sign means I am the owner of the money. Now, when I multiply, I'm able to get plus 2. When I add, I'm able to get this plus 3. Then, I will eliminate the middle number and put plus 2 and plus 1. X squared plus 2x plus x, then plus 2. Then, what is common in both? I have x is common. Open your brackets. When x squared divided by x is remain x plus 2x divided by x is remain 2. Then plus, what is common here? Absolutely nothing. You are going to put 1. Open your bracket, s plus 2. What is in this bracket must be the same thing here. So what is outside? X plus 1. Then you pick one of these, x plus 2. Definitely, the factors of x squared plus 3x plus 2 are these in bracket. So when you factorize this one, you must arrive at this. So coming here now. Coming back here, dy, integral dy equals to integral x squared plus 3x plus 2 over x plus 1 dx. Now, integral dy equals to integral. I'll solve this one to get this. I have x plus 1 and x plus 2 divided by x plus 1 dx. This cancels this. Integral dy equals to integral x plus 2 dx. Now, let us open bracket here. Integral dy is equal to integral x dx plus integral 2 dx. When you integrate dy, I have y equals to, I want to integrate this x power. Don't forget x is the power of 1. 1 plus 1 over 1 plus 1 plus, when you integrate a constant, we have 2. We're talking in terms of x power 0, because x power 0 is what? 1. And to integrate, you have 1 over 0 plus 1. So y equals to x squared over 2 plus 2s, introduce a constant c. So this is another way of setting this integration question. We have come to the end of this second class. If you find this class so interesting to you, kindly subscribe to my channel and click the notification bell for my subsequent content. And do not forget to share, like, and love as you move on. Thank you very much. See you in the next class.